Hey guys, welcome back to this tutorial, and this we'll be talking about Numpy and then Pandas. These two packages are very important and then fundamental to the data science industry. We'll be looking at it from the point of what we need them for. They are useful for other things even outside of data science, but in data science they are mostly used for data manipulation, how to construction of data, and then to generate test data sometimes. Numpy is a package that works with list and arrays. It has faster arrays for computation, I mean mathematical computation, than the normal Python arrays. So, and then we'll be looking into that. First thing first, we need to install this on our computer. So on, or should you call it on your workspace. We use Anaconda, so you should go to the Anaconda prompt. You should open the prompt, not the navigator. Open your Anaconda prompt. It should log you into your main the base, what's it called, the base environment already. So you need to install these two packages by running this command conda install numpy then pandas. These two, just click this and then you should be good to go. Wait for it, give it time, and then follow the instruction. It should ask you for some kind of yes, press the yes, and then you should install this. It takes time. I already installed it before. I just show you guys. So after installation, you can close the conda prompt, wait for it to be done. You should see the successful output on your terminal before closing this. So after closing, then come here, then search for Jupyter Notebook. After installation, you can now use it in your Jupyter Notebook. Click on this and it should open your Jupyter. You understand? So after opening Jupyter, then you can now come here, create some files. This is how I manage some of my files. I create a workspace folder. So you can go to your file management on in your username, or in your username folder. Create a workspace or a learn space. That is this is the folder for everything you are learning. So create a learn space, then you can create a data science tutorial folder under that. Then under it, you can now create a numpy pandas folder. Let me show you guys how I did my own. You can see here, this is workspace, because this is a work for me. You can name this learn space for you. Then I created a tutorial for this tutorial. Then I created numpy and pandas. That is a tutorial for numpy and pandas. So after creating those folders, then you can now come, you can create a file. When you click here, then you can create this one. This is what you do. Create this, then name it numpy. So after name it numpy, then you will see something like this. So the first thing, let me delete all this I've written before. So the first thing you do when you want to work in Jupyter or any notebook is to import some packages that you want to use. So now let's import a package. We are just working on numpy here, so you can now import numpy. Import numpy as np. This is, we are just telling Python, or we are telling this our program, that anywhere we call np, we want what we want to so anywhere we are calling np, we want to call the numpy packages. That's what we are just saying. Anywhere we call np, we want to call the numpy. So that's it. So when we import like this, we are telling this program that, or the Python or the compiler, that anytime you call np, we want to call numpy. So yeah. Now let's see what numpy is used for. What can we use numpy for? This is just like an introduction to NumPy. There will be a lot of packages, a lot of no, a lot of functions we are not talking about. But this is just like an introduction. After this, you can be able to do things yourself. And if you need more, you can definitely find it yourself. Now let's get it done. First, let's create the normal array in Python. This is Python array. So this is a Python array, right? So you see, there's no shape in list. So I'm trying to check something now. You see, this is array in Python. R1, this is it, and then R2, that's it. Let's create the third array. That is, we make it a two-dimensional array that has the two arrays inside it. When we talk about two-dimensional array, it just mean an array with length, the y-axis and then the x-axis, the length and then the width. You understand? So let's see the array theory. As you can see, this is one and this is two. Now let's come back to NP. We want to turn these arrays to NP because we said NumPy arrays can make our programming very fast. Oh, now let's do this. N array1, that is NumPy array1 equals to np dot array. So that's how you do it. np dot array. You can do this, copy this and paste it here, or just do r1 and put it here. So you can do anyone, but this makes sense pass because you don't need to create this before you can do this. You can just do this directly. Now let's do the nr2, and then we can do np dot array, then paste this list or paste this array inside. You can see. Now let's do nr3. You can do it the way we do this, np array, then copy this, right? But we don't want to create anything before we can use it. You can see, just first you want to bundle the two arrays inside an array. You understand? At the end of the day, we have only one list with a lot of lists inside it. So then we take the first list, we put it here, then we take the second list, then we put it here, as you can see. Now okay, for you to do this, one, you can see in NumPy, the list must have the same length. 1 2 3 4 5 6 7 8 9 10. 1 2 3 4 5 6 7 8. That's why we are getting an error. You can see in normal Python you can do it directly without any issue, but in NumPy they must have the same length. You can see everything works fine. Now let's do r1 dot shape. The first function in NumPy you should know is the dot shape. So if you create an array in NumPy, you can check the shape, because normally NumPy expects you are creating different dimension of array, not just you. So you are not just going to check the length of that array, you are checking the shape of the array. So now let's see the we are using the normal one, so we should put the n. As you can see now, this is the array we are checking, so we can delete all this or we can comment it out. So this is the list or the array we are checking the length, and then it is telling us this array has 10 elements inside, but it is one dimension. That is 10 elements with no dimension, just a straight vector, nothing like a dimension inside. You understand? If you're a mathematical student, you should understand vectors. So all these things inside this array are the scalars, and this general array you can call it a vector. So this is a straight vector. Now let's check for the array 2. As you can see, It said it has 8 elements and it is also a one-dimensional array. Now let's check for 3. 3. You can see now the number of elements comes here. In your head you think the number of elements in this comes here. No, and then the length. This is the length of the array. If you understand what we are saying now, there is one array here. This is an array, and this array has the element of other arrays. That is, we are storing arrays inside an array. So this, what we are saying is, what is the length of this first array? It is 2. That is, there are 2 arrays, there are 2 lists inside our first list, our main list. Then each of these lists consists of 10 different elements. That is why if you are using the nd arrays in Numpy, they must have the same element. So as you can see, this element must be the same with this element. Now let's try to create a 3-dimensional arrays. How do we know the dimension of an array? We know the dimension of array depending on the numbers of elements that is being output from your shape. So we have 2 elements here, so this is a 2-dimensional array. Now let's try to create a 3-dimensional arrays. So let's call it, no, let's come here. Okay, I will try. So these are vectors, right? You can call this 2D arrays or matrices. So this should be matrices. Matrices are 2 dimensionals, right? I'll bring it here, and then this should be normal Python list. So these are the number. If you remember to check the normal Python list, the length of it, you can use this function. Don't forget, we already talked about this in the last class. So this function, so which will give you you can see this is 10. It will give you the length of the array. Now, for here to check although if you use learn on these two, it is going to work, but the best function to use for this should be what? Should be the shape. You can see the learn is going to work, but the shape is the best thing to use. So let's do this. Fun fact, this is good to check the dimension. To check the dimension of an array, this will work. You can see, because this is one dimensional, but let's leave it this way. The shape is returning a tuple, if you remember in our last class. So the length of this tuple is 1. So this is one dimensional array. Now let's come here, and then we have a 2-dimensional array. Now let's go to 3D arrays. So this is a 3-dimensional array. First, let's see the shape. You can see we have three output here, so 3-dimensional array. But let's do it ourselves. So let's call it n4 equals to np dot array. First, we have the main list that is going to store all of our arrays. So I created this to understand, to make you guys understand what 3D arrays are. The rules that we use in 2D arrays, that all the length must be the same. The length of everything here must be the length of everything here. Now let's go for 3D arrays. Now we want to recreate this thing I create here. So let me explain how these things are done. So I'm coming. Let me check the shape first. I don't know, you actually do not need 3D arrays for now, but still we need to tell you guys it exists. You understand? Now you can see it was a 3D array. Now let's go back to now. First, when you're creating an array, the first thing you need is this bracket. You need this bracket, right? You need it to compile or to save all your arrays. Now let's come here. We said we want a 3D, right? So we need three other arrays here. One, two, three. Do you understand? I'm coming. I'm trying to create a simple one if this is going to work. This is not 3D, it is a 2D array. You understand now? So it is not 3D. So after this, because we just create different list, the hierarchy of the list is just two here, right? First list, then we have three other lists. Now we need to create one more list inside of this list. Okay, as you can see, we for this to be a three-dimensional array, there must be an additional array inside these arrays. As you can see, if we make this three-dimensional array, it is going to be, you can see, 3 1 3. At the end of the day, this our main array. What is the let's do it like this for you to be more clearer. So this is the first array, and then the second one. So you can see it clearly like this. So this is no, the length of this is what is 3. Then how many arrays are inside these 3 arrays? We have just one arrays each inside them. Then how many elements are in each arrays of this array? Then we have just 3. Now let's make it 3 2 3 arrays. So now add one more here, add one more, then add one more. There will be an error because the length must be the same. The number of elements in them must be what? The same. Let's just put 3 2 3 4 here. Remember, okay, yes, 4 5 6, then 6 7 8, and it should work. No, there's a comma here. As you can see now, we have two arrays each in these arrays. Do you understand now? Then if you want to make it 3 3 3, you can just add one, then add one, and we have 3 3. Let's say we want to have 3 3 4, just add one element each here. Remember, if you're adding anything, you must add it for all. So just play with these things, play with the numbers, play with every. At the end of the day, before you were working with 3D arrays, it will take a lot of time. You can see now 3 3 4. Now we are done talking about ND arrays, and now you can have more than 3 arrays if you want to make it 4. If you want to make it 4, we have 3 here, then add one here. This will be 4. Let's say you want to make this also 4. All you have to do is add one inside each of the array, and if you want to make this 4, add one element inside each. So that's all about that. Okay, as a quick one, let's create a 4D arrays, 4-dimensional arrays. This is going to introduce us to what a function in Numpy, and then we can also see 4D arrays. Now let's do this. You see, D is np dot zeros. Notice this function. Np is the package, dot zeros means for this array that we want to create, just put zeros inside it. So just put zeros inside it. Let's do this first. If you don't want to do this, put in 10. This is going to create normal, you can see normal arrays, and you have 0 0 0 0 0 inside. Now we want to create a 4D arrays. If you remember the dimension, you can see this is one dimension here. If you want to make it 3D, just use this dimension here, and you can see that there will be a lot of zeros, similar to what we have here. If you remember, you can see now it is similar to what we have there. It is 4-dimensional, as you can see. So this is I mean it is 3-dimensional. Sorry, this is 3-dimensional. Yes. Now let's make it 4. Let's make it 4. Let's say you add in 4 here. So this is 4-dimension. To check for the dimension, just do d dot shape, as you can see. Right. So if you want to create a 4-dimension yourself, all you need to do is go deeper in your list. If you remember here, we have just to make this 4-dimensional, all we have to do is just add a bracket at the back of all these numbers. That is, we are creating another list inside them. Another list. You can see, if you add in one bracket in here, so all it has to do is just it will add one dimension to our list. The more you go in with your bracket, the more dimension you are creating. So this is going to create the 4-dimension for you. As you can see, this is just us playing and letting you see how powerful. This is a lot of dimension already, and it can handle a lot of data. At the end of the day, this is the building blocks that AI and everything is based on. You can see, and we have a 4-dimensional arrays. So that's it. Now let's just move away. But if you notice this function, useful functions. Let's say these functions are very very useful. You want to create a list of zeros, and then instead of doing this, you want zeros. Instead of doing this 0 0, let's say you need 100 zeros in this your list. Instead of doing that, just use this function np.zeros and then put in 100 here. So this is dimension. Put in 100 here, and you should be fine. Print it out, and you have a lot of zeros already. Now you can also do it for ones. np.ones, and you have 1 1 1 1 1. That's it. Very very powerful. Very very powerful. Do you understand? It is very 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 powerful. Now let's look. Let's not delete the zeros, so you can also use it, zeros and the ones. Now let's move forward. Now let's look into another function. This function is called a range. A range. We're telling MP to create a list for you that range from, this is the syntax. A range, the start, the stop, and then the step. So you can do, if you don't want any step and then it takes the step automatically, that will be 1. You can see 0 1 2 3 4 5 7 8 9 10. So from 0 to 10, so 10 exclusive. Then if you want it to, you want to show the step, you can add the 2. Then it goes to 0 2 4 6 8. So this is also a useful. And then there's also I think a lin space, mp.l. So what you are telling this function is, okay, I want 5 evenly spaced object letters or numbers. Sorry, I want 5 evenly spaced numbers from 0 to 10. So it is going to take in the spacing itself automatically. Let's say we want 6. As you can see, this is 1 2 3 4 5 6. Let's say you want 7. It takes some step automatically. You can see now. So you want 7 evenly spaced, and this can also be it can be very, 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 very useful. Now, let's say we are done with that. So there are a lot of functions. As you can see how powerful and how big these functions are. Now, mathematical functions that will be useful for you in when you are doing data science. Let's say we have arrays equals to np dot a equals to np dot array. Then you can have 1 2 3 4 5 6 7 8 9 10. Now let's see if a is fine. Okay, there's a syntax error here. Then now a, what, another one again. Oh, sorry, make it a list, not just a. As you can see, yeah. Okay, now we want a dot main. That is, what is the main number? No, sorry, it is np. You use the np dot mean, then you pass in a. This is the mean. That is, the average in this list is what, 5.5. Let's say we want to sum all this together, and then it is going to plus together for you 1 plus 2 plus 3 plus 4 plus 5 2 plus 10, and then we have 55. So these are also one of the importance of np. Now let's say a equals to, I want to show you, this is the normal Python function, right? So a plus 2, if that's going to work. You see, now this is normal Python function. We cannot do this with Python. But let's go back to the np arrays, and then now we can do some linear calculation. You understand? Linear, this is a vector. Now, in your matrices, this is a vector, and then if you plus it by 2, it is going to work. And what is it going to do? It is going to plus 2 to every scalars or every element in this vector. Do you understand now? Let's do a times 2. The normal Python, this is not going to work, but with this, it is going to work. Now, let's say you want to do, let's say b equals to np dot array. You see, one beautiful thing about programming is you can always do try and error when you are learning. So let's do this. This should not work. A times b, and you should have an error. You understand? So they must be the same what? The same shape. I mean the same length. Okay, let's do this first. 5. So we have 9, it remain 1, and then it should work. 1 times 1 is 1, 2 times 2 is 2, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 25, 6 times 6 36, 7 times 7 49. Let's just 7 8. So we can just have square of the numbers. So you can see these are the squared, because we have the same number, and when you times it, you just have the square. You can see this is a times b, and we have it. We can do a divided by b also, and it will work. We will have 1 because they are the same number. So, or a raised to power b. You can see this is power here, times is power. As you can see, 1 raised to power 1, 2 raised to power 2, 4, 3 raised to power 3, 5 raised to power 5, and then they are all good. Now let's do some kind of matrix calculation. In your matrix, when you want to let's do this. Let's make this a two-dimensional array. Two dimension. So two dimension, they must be the same thing. So this is matrix now. A times b. You see, it is going to give you what's this doing? If you understand what this is doing, first it multiply this by this, then it give us the first row, then multiply this by this to give us the second row. Let's get this 0.5. You understand now? 0.5. 0.5. When you type something by 0.5, you just want the half of it. 0.5 here, 0.5 here too, 0.5 here, 0.5 here, 0.5 here, 0.5 here, and 0.5 here. Now let's see. You can see now we have 1, 4, 9, 16, 25, because this is multiplying this by this to get the first row. The second row is yes, you see, let's make it a matrix. A matrix, this is the first row and this is the second row. So when you are doing matrix calculation, what you are doing is just multiplication. You multiply this by this to get the first row, then you multiply this by this to get the second row. Do you understand now? So first, let's look at the first one. A is a one by one matrix, and then B is a two. Wait, to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is 1 by 10. We have one row and then two. Okay, if you remember, a matrix is what? It is the rows by the number of element, or the row by the column. So we have a 1 by 10 and then 2 by 10 here, if you understand. And then to make a matrix multiplication, let's see this. If you do this, it is going to give you an error because it doesn't. Okay, it works the same way. Why? Wait, okay, because yeah, calm, because this is a scalar. If you are multiplying by, this is just a vector, so it should work. That's why it is working. Sorry. Let's say you add another here. It will work because they are both okay. No, okay. It is the creation of this that's wrong. So we are already doing some linear calculation already. As you can see now, this is working. But you see, it is not the same as the old one now, right? Because this and this work together to give you this. If you notice, 1 times 2, 2 times 2, 4, 3 times 3, 9, 6 times, you understand? Then we have 100. Then this and this also works together. So for you to understand, let's do 10, 20, 30, so 40. As you can see, all of these are going to change. So these are just matrix multiplication. Then you can say this is easy. If you're just talking about just normal Python, you have to use some kind of loop for everything in the row, for everything in the column. This times this, so that's going to take a long time. But with Numpy, you are doing everything easily by just using the normal mathematical operators. So that's about matrix multiplication. And then addition, you can do subtraction and all. So this is just an introduction. We don't want to get to this, is getting too long already. Now let's move forward. Now before we move to pandas, let's talk about indexing in this. Now let's just go back. We need this. Okay, let's use this too. Okay, let's use this to be able to understand well. First, let's use this. Let's say you want to index the third number here. We do it as the normal indexing in Python, normal Python. Let's see. You need the third number. If you remember, indexing starts from 0, so we need the 2. And then what's the third number? 3. You understand that, right? Now let's come here. But this is very, very different. This is not just one dimensional. This is two dimensional. We have 2 rows and then 10 columns. What do you need to? Okay, let's say we need the 1, 2, 3, 4, 5. The fifth number in this second array. So we are dealing with the second row. If you remember, if you do it like this, you understand what I'm saying. So this is it. This is the first row and that's the second row. Let's say we need the fifth number in this second row. How do we access it? So you need indexing. Then you can now say NR3. You see, right? You see here. What row do you need? You need the second row. That's one. You know, if you remember, it starts from 0. Then what column do you need in the second row? We need the fifth one. That's 4. Let's comment this out and then let's see what happens. You can see we have 5 out here. What is the fifth number here? 1, 2, 3, 4. We have 5. Or if you do the sixth, you have 9. Let's say you want to take the sixth element in the first row, then change this to 1 and then you have it. So that's how you index. Now let's go to the three-dimensional. How do we index in three-dimensional? Here, this is four-dimensional. Okay, I think the C here is three-dimensional. Let's just see. C. This is three-dimensional now. Let's come here. C. Calm down. First, let's do this so we can see it well. Then this. As you can see, this is one row. This is the second row. You understand? So C. Let's say we want to deal with this row. How many rows do you have in the C? You have 2 rows. If you remember, you have 2 rows. Now, let's say we need the first one, 0. Then what do you need in these 2? How many elements are in each rows? We have 2 lists in each rows. Let's say we need the first one also. You can see very easily. Now, what do you need in this? Okay, we said we need the first one. That is, we are taking this list. What do you need? You also need the first number there, and then you have 1. You can say that's how you index. Or let's say you need the second number, and then you have 2. Let's say you want to take this 3, then change this back to 0, and then this is what the second element here. So change this back to 1, and then you have 3. So that's how it works. That's how indexing works. You just follow through like that. So that's all you need to know about Numpy for now. But know that we are moving to pandas now. Let's create a pandas. Let's create a pandas file. But remember, pandas is an extension of Numpy. Is an extension of what? Of Numpy. The developer takes Numpy to another level. Numpy works with numbers, but pandas it works with list and all, and it uses numbers for the indexing. But pandas take it to the another level by introducing something we call series, and then from there you can now use alphabet or letters or words as your indexing. Now let's come here for you to understand what I'm saying. Pandas. Coming. Okay. The smallest building block. Okay, the first thing we do, let's do import pandas. Import. Then can now run import pandas as PD. Okay, the smallest building block in pandas or the least building block in pandas is called what? Series. They are called series. Now let's say S equals to PD dot. Is it capital letter or small letter? PD dot series. Yeah. So as you can see, okay, it is working. Now let's say series expects some. You can create series in 2 ways. Let's use the first one. If you remember this is a dictionary. This inside it is a dictionary, or we can call it a map. If you remember, it is called a map. That is the index and then the value. So now let's do A is 100, B is 200, and then C is what? 300. Now let's look what's going to happen here. Okay. So it is capital letter. As you can see, this is a series and it is a type of int64. So a series takes your map to another level, and then uh as we created a map here. If you want to understand better, let's take out this map. Let's say data equals to this, and then series is you can see now you have A, B, C. Oh, are you getting me? That's a series. So, or this is just a list. If you remember, you can also create this with a list. But the reason we use the the dictionary is for the indexing. But at the end of the day, Pandas is using a dictionary to do all this. But now let's come back here and use a list instead. We said 100, 200, 300. Let's see what happens. You see, this works, but we are given some indexes automatically. We do not declare any index, so we are giving indexes automatically. Let's say you want to create your series this way and you want to give it an index too. This is what you do. So let's give it index equals to a, depending on what you want to use. Before list, the index of a list will always be what? There will always be a number, but now we are getting a way to like index our list with letters. So that's what series are, more like a list with custom index. You can use numbers, you can use anything as your index, and they work fine. See, let's do this. See, you can see now S and then A is what? Is 100. So this index is also a list. So everything here will be mapped to the corresponding index here. Do you understand now? So this is a series in Python, in Pandas. So we have a series. What do we have next in Pandas? We have a data frame. We have a data frame. This is the most important. It is the most important type, or a data type in Pandas. It is the reason we can work with different files, different like CSV, TXT, and then a lot of other things. They take everything from this CSV and turn it into a data frame. So what is a data frame? A data frame is a collection of series. So we have a series here. So let's create a data frame uh automatically ourselves. Let's create it. I think I said automatically. Let's create it manually by ourselves. Now let's get into it, guys. Now let's go to Pandas. So we have a series here now. We can also give our series a name. We can give it a name. Name equals to S or something. Now let's do it again. You can see name is X. Now let's work like a real data, a real life data. We are working with some kind of students data. Let me use this as a reference. We are going to use this later. So a CSV file, we have the ID, we have the name, we have the age, we have the gender, we have the math, okay, math, English, science. The ID, name, English, gender. So the student data that I want to see, it is kind of showing the marks for each student with their ID. You understand? So now we can create different series. We said our data frames is a collection of series, right? So now let's say our student ID equals to what? At the end, you don't need to index it. The 0, 1, 2, 3 index is fine since we are moving it forward. So we don't need to give it some kind of custom index again. So now the student ID, how many students do we have? Let's say we have 5 students. So this 5 is normal. Then you name this ID, as you can see. So it is going to give you this custom 0 1 2 3. You can see now. So we have 5 students. Now let's create student. What's the next thing? The name again. Bring this here. What the fuck is what? Bring it here. Give it name it name, right? Then Alice, Bob, Charlie. You can use anything you like. Comment this out. You must have 5 names here. At the end of the day, the length of this must be equals to every other length. So the 5 names must be there. So that should work. As you can see, we have 5 names. Now we are trying to create this. This is a PDF file, a CSV file. So let me open it in another file for you to see. In a file editor for you to see that this is a CSV file. We are just trying to recreate it. That this is the file here, right? So when we click on it, it is a CSV file. As you see some no, this is it. All those things you are just seeing there are just some kind of beautification that's done by Jupyter. So it is a CSV file. Now let's move forward. So we need the age of these students. So we can copy this students what call it student ages. Then you can have 21, 20, 24, 18, 19. Again, name this what age. So let's confirm it is fine. As you can see now, what do we need after that? We need the gender. Okay, we still need a lot of things, so we should be fast. We need the gender. Gender should be alphabet, so we can copy this one. Gender F M M. Wait, okay. Alice is a female, Bob is a male, Muhammad is a male, Idris is also a male, and then Ola is a male too. Let's do this as Ayo, so we can have two female. A female. Then name this gender. So student gender FFF. You can see that one is fine too. So now we have how many? Math, English, and science. So we can use this. $78. You can use any number, no, not a must to be that one. So that's math. And we need what? 3. English, then science. Now we said, so we have all these series. Do you understand? We have all these series. Now let's do something. we want to turn this to a what? A data frame. What is a data frame? So now let's see it. I'm coming. You can see if you run type on this thing, it is going to tell you it is pandas.core.series.series. So it is a series type to check the type of this file. Now let's turn all this to a data frame. We call it df, so data frame. Now you can now use pd.concat. Now you have to bring in all of this here. So at the end of the day, if you want to create a data frame, you are not going to take this route, but I'm trying to show you how pandas work in the background, how they create a data frame. Everything starts from a series. So, and this is how we can accomplish it too. And then we are going to show you how to create a normal data frame without doing this. So now, we have something we call axis. So it depends on what you want all this to be. If you notice in our data, they are what? They are they are columns. All those series are columns. So the axis we call columns is the axis 1, this is axis 0, and this is axis 1. Everything here is the 0 axis and everything here is the 1 axis. So divine axis here equals to 1. So now let's see what's going to happen here. df, as you can see, from what we created: ID, name, age, gender, math, English, science. You see, it is almost the same as this. You can see that everything is normal. So if you want to, you can decide to remove all these indexes here, but let's do that another time. Now, we have a data frame that we all created from what? From our series. Now let's say you want to get your science mark series back from this data. What are you going to do? Let's do this. LC mark. Let's say we want to get it back from our data frame back. This is what you're going to do. Just do this, and then you need to index. You need to index this by what? By everything here, by all this thing here. So let's say we want the series for our science back. All you have to do is just do this. See, now run this, and you will see it will be the same as what we have here, and it will be back to series. As you can see now, let's run this back. Run this. Run this. As you can see, they are the same. We get this back from our df, and then we created our df from this. So data frame is just a collection of what? Of series. Now let's teach you how to create data frame uh, on a normal day without doing this. We are going to create the same data frame but with different way. So this is what we're going to do. Now let's say you can now say data equals to, now can create this. You can use something like this, where you have your index here. You have the index here, and then you have the data here. The data will be a list. So the index will be the name of what you want to do. That will be, let's say we have the names, the name. So this is the name here, and then the data is this. So we have the, instead of creating a single, instead of creating different series for each, then you can just create all of this in one what? In one dictionary. Bring this here, comma. This is also another way to create what? uh age, we have gender. What the heck? I put a comma here. We have gender. Is that fine? No. We have gender. You can name gender, maths, English, then science. So let's just copy the two here. This is English. What the heck is this now? This is English. Then science here. This is science. Then we need the ID here, right? For it to be complete. ID. I think you all know how to create a dictionary. We did it in the last tutorial. So this is the ID, as you can see. Now we want to make this a df. So df equals to pd dot sorry d df equals to pd dot data frame. Then you put in the data. Now let's run df. What do you think? The same thing as this. The same thing as this. Let's run this again. Df equals to, you can see the same thing here. Okay, this is our custom df because we are using customization way to do our thing from what is it called directly. This is our custom df, and then this is our df directly. As you can see, they are what? They are the same thing. We created it differently, but at the end of the day, as you can see, which one is the easiest one? This one is too long. We have different number, we have different variable names and all before we can get to this. And this one, very straightforward. At the end, you can decide not to use that data and just cut this, put in here, then remove this, and at the end you still, what the heck? Okay, and at the end you have the same thing again. Now the third way, this is a, let's call this dictionary data frame. So this is how we create a data frame from a dictionary. Now let's create a data frame from a list directly. Df dot let's call it df equals to, another way to create a data frame, pd dot data frame again. Now you just put in a list, the name of the columns, right? The name of the columns. Okay, to create a data frame from a list, let's do this. The data frame. So your data frame is a list, then everything that will be in the data frame here. Now you can start having them, can start putting the data there. The first one is the ID, right? 1 2 3 4 5, comma, we have the names. Alice. If you notice, this is getting so clumsy already. Unless you want to add just one or two the data, you understand? Or you can do this. Let's say right? Is a list. Then you have the ID here. 1, 2, 3, 4, 5. Let's see what's going to happen. You can see 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Coming. Because this is taking just if you add no column, it is going to take it as x axis, not the axis one. Now you can add a column of, we need ID, and then we need the name. For now, let's just do it this way. Okay, there's an error. Data add 5 columns. I'm doing something wrong. Let's go back how we should have do it. Let's do this way. Should get an error, right? Again. So I'm coming. So if you are doing this from a list, it must be. So let's do it again. This is it. Data frame. Okay, it is a list of lists, right? So we need a, based on this column that we defined, for each list we will have the ID, then we will have the name. Do you understand? We will have the ID, then we have the name inside each list. I'm so used to the normal dictionary of creating, so that's why. So this is the second one. So this should work. I'm coming. Close this, close this, then close this. As you can see, it works fine now. So that's what it means. So if you are going to use list, for each of your list, all these things must be present. So as you can see now, this is not even better. I feel the best way to create this data frame from scratch is by using this. I love and I love this a lot. So this just said, okay, this is all our IDs, these are all our names, this is the ender, and the DF will take it automatically and everything will be fine. And this also, for some people, it seems more organized. That is, for each entity in your data frame, you have the name, you have the ID, and then you have the mark. So you can do it this way. Now, let's say we already create, we don't need this again. We already create our dictionary. Let's say we want to save this. You can just do the dict dot to CSV. As you can see, give it some name. Uh, let's name it df.csv. Then comma. What should, let me see this function. I don't want it to include the indexes. Is this one running? Let's run this again. Okay, we have the df now. Put it here. When you save this, okay, shift enter. Okay, let's go back in. As you can see, a new file here. It saved our file. And this the uh, the numbers and everything we created ourselves. Then we save it to a CSV. As you can see, Pandas is a very, very, very strong language. From we created the data file ourselves. You can create some text data file that you can use in machine learning by doing this. So we have a CSV file. Let's see it here. As you can see, this is the DTF. You can go check it. And we have a CSV file that we created from scratch all by ourselves. Now, let's say, this is our the student CSV, the CSV that comes with this tutorial. Now let's say we want to read it. So let's say our df equals to, there's a panda function called read CSV. You are going to use it a lot. Read CSV. So when we are working with programming or with Panda or in data science, we are going to use CSV files a lot. They are going to give us some CSV files to work on. So this is how we are going to read it, and we are going to save it as a data frame. I'm not the one that created this student.csv, right? So now let's read it. Yeah, we run its df. You can see we did not create it ourselves. Someone gave it to us. Now we can use it. Let's say we want to get the names in this file. You can say df.name and you get a series. If you remember, you get a series. Let's get the age. You can see something we didn't create for ourselves from someone else, and we can work with the gender and then math, English, then science. So that's it. Science, let's say you want to get the first element there. You can do your indexing this way. Then there's another way you can index in, so in data frame we call it ilog. So let's do df.ilog. So let's work with ilog for just a moment. Ilog. Let's say you want the first. What's it going to show you? It's going to show you the series for the what? For the ID, because that's the first index. This data frame has two index. If you use ilog, you can use this the numbers to index it, and if you use the normal one, then you can use ID. So this thing and this is just the same thing. But ilog can be very, very useful. Let's say now ilog, take the first one. Coming, then you see when you use ilog, then you can use dimension to index. If you remember when we talked about dimension before, the shape of this of something. So you're saying take this the value at this dimension. So what's the first zero here? What's the zero index here in our file? This is the zero. Coming, this, I think this is the column, this is the row. It shouldn't be. Why is it showing? Okay, let's run one and zero. So okay, in ilog, the word comes first. What you need come first, then the row is the second one, right? So you just do it. For this one, it's going to take uh the first column. So that's true. So this is going to take the column if you use one. But let's say you are going to use two, then it is going to take what? This will be the column, this will be the what? Row. You said the first row in the second column. So let's say the first row in the first column, you do this. You see, first row, first column. Now let's say you want the first row, but you want the second column. So this is going to show you this at least. Okay, we want the first row still, but the third column. So do this, and you have the third column. Yes, you have. Sorry, third column will be 2, not 3. You have 16. So fourth column for gender, you have 78. A for gender, F for 78. So now the same thing, maybe you need something here. So you can, let's say you want to get this with iLock. What's this? It is the what? It is the fourth, what's it called? No, the third row, then the second column. We have a Diana. Okay, sorry, now four. We will use four still because it already start from okay. So you can see we have zero. We have Edward. So yeah. So that's what iLock is for. And then you know we will be working with a lot of things. Let's say let me show you one of the most important function in DF. If you run df.describe, you have a lot of things to run df.describe. It's going to describe the function. It is going to describe the table. As you can see, we have the numbers of element in each column. You have 5 IDs, 5 age, 5 math, 5. So nothing is missing. It's going to show you the mean. It's going to show you the standard deviation, the minimum value, the 25% percentile or the 25 percentile of the data. That is the 25. What is okay? That is less than or equals to 25%, or less than or equals to. You mean what we call the 25% percentile is it is greater than or equals to the 25% of the data. So the same thing for the 50 percentile, then the 75 percentile, then we have the max. So yeah. So let's say you want to get the minimum value in each column. So you can just run this describe, then come here, then you do the minimum value in ID is 1 because they start from 1. The minimum age is 15. So you can tell that the youngest student in our school is what? Is 15 years old. And the minimum score in math, that is the lowest score in math is 67, lowest score in English is 60, lowest score in science is 65. The highest score in math is 92, highest score in math is 90, and highest score in math and science is 93. So this can help. Let's say now in so we want to create, so this is our DF. These are all our columns. Let's say we want to add one more column. It is called coming. So let's say DF passed. Let's say the student that passed equals to DF. Let's use math as the benchmark. So we are just trying to do something. And we say anybody that scores, uh, let's say fail, because most of the mathematics kind of passed. Let's say anybody that scored less than 80 has failed. Makes sense, right? So we add a new column to this. So as you can see, it will show you some new column. As you can see here, you see true, false. It said anyone that scored less than 80 in mathematics has failed. So this person here scores 78, so they failed. This person here scores more than 80, so they didn't fail. This one scores less than 80, they fail. This one scored more than 80, they didn't fail. And this one scored less than 80, they fail. So you see, we add another column that we didn't add in the first place to our data. Now, what else can we do? Let's undo missing data. Let's undo missing data. Let's say df grade equals to none. I'm trying to do something. None. Let's run it again. Or you can do this. Let's do any ns. Is any the right? No, coming. To show you guys how to manage null data, let's go and edit our file. This student file there, let's edit it and input some kind of null file. Let's delete the one here. We didn't put anything here, right? Then let's delete this here. We didn't put anything here. And let's see. So let's save this data. Let's come back here. Let's where did we import it? And let's go back here and rerun it. So you see here we have NaN, so it is none. That's what I'm trying to know. It is NaN because we have nothing here, and then we also have nothing here. So let's come back here. Let's do describe again. Okay, include equals to all. So this is going to show all our you can see here. Now let's see the count. We have 5 IDs. We have 4 names. We have what? 4 names because there is one non. There is one name that is not there. We have 4 names. Age we have 5. Gender 5. We have math also 5. English 5. Science also 5. I think we deleted another one here, right? What did we delete? So we delete the math here. That is because I think it's represented it as 0. So that's what happened there. So they will represent it as 0. So if you go to the minimum here, min for English, it's showing none because there is nothing there. There is nothing there showing none. So, this is it here. This one here. Now let's undo missing data. We know in our data now we have some kind of missing data here, right? We call it null and none. So how do we manage it? So let's come here, open new file. Now let's say df dot is null. It is going to show you everything that is not there. It's not dot sum. Let's run this. You see, I saying how many data are null in this. So they said ID, there is no null. In name, there is one null in name. I don't know why they are not showing the math because I think they are just representing it as oh shit. Okay, yes, it is the same thing, yeah. Let's just do it like this and leave it that way. Okay, I'm coming. Let's rerun this if it is going to work the way we want. Yeah, so you can see it's not right, right? So I kind of get the reason it's doing that before. So run this. So we have 4 in math also, and then we have 4 in name. When you see others having 5 and some others having less than that, that means there are some kind of null data in your data. So you need to manage that. So it's null. You can see here. So to know how many null or how many missing data are in your file, just run this. Df dot is null dot sum. It's going to show you. So this one is 0, this one is 1, this one is 0. So we have math. Math is missing, and then what's missing again? The ID is missing. So what do you do when you have missing values? You have missing values, you have two options. You have two options, and these are your two options. You have more than two options, definitely. You can find since this is a very small data, let's say we have thousands of data and you are saying 700 nonce or something. So definitely you can use this one, drop any, or you can use the fill any. This is going to work. Let's use this first and you should understand what it means. That is fill the any with zeros. Matt is 0 and then Alice is 0 here. Alice is a name, so this may not be a very suitable way to manage your missing values. Do you understand? This is what you can do at first. So, or you can do this. Let's do this. DF will drop any, and it is going to drop all those index with what uh with all those index with null value. If you run this, you are saying in place equals to true. That is, it should not create new data. That data should remove, because if you don't use in place, you can see now we have our data without no null data. Do you understand now? So yes, let's go back to our file and just just go back. We don't want any null. So yeah, we have it again. Now you can come here. We run this. Come back here. This is where we import. Run it. Download file. Check if there's any null. Describe it. You will see everything will be 5. Then check if there's any null, and there's no null. You can see 0, 0, 0, 0. Now let's come down here. Let's try to do some kind of sorting. Understand? df sort h. Oh, that I don't think that's a function. I'm coming. So let's say you want to sort your this. Let's say sort values with age. See now, I'm coming. Okay, I think df. Okay. Sorry, man. I wasn't using the right thing before. I was right with this, so it should be basically right. So sort it by age. Why are you telling this? We are telling it to sort our data by what? By age. You can see it's coming from ascending order. The default one is ascending 15, 16, 16, 17, 17. You can see it is sorting our data in different way from the default one that we send it. This is our first data. We have it in the second one now. You can see all of them. You have them in different ways now. Let's say you want it you want it in descending order. So you want the oldest people first, as you can see 17, 17. So it is sorting your data based on the value from this age. So you can sort data. And now let's talk about this should be sorting. You can sort with the mathematics mark or something. Let's say you want a student with the highest maths mark at the top. So this is it. Or you want it at as how low the score in maths. You can also do it like this. So now let's talk about filtering, right? So let's say from our DF, the same thing that you get here. Okay, no, this is filtering, not. Let's say we want everyone with the age greater than 16. Sorry, with age is greater than 16. As you can see now, we have just two. You can call this as filtering. So we have just two students with age greater than 15. Let's say we want students with their math score greater than what? We did something similar here when we are doing equals to less than, or so we are doing fail and true. So let's say we want those students that has scores that is less than 80. So you can see them. So if you want all students that failed and they said the criteria for failing is when the scores of mathematics is less than 18. Or let's do this. There's another way you can do. So let's do this. We want to do the average mark, right? Plus df English. Are you seeing it? plus df science divided by 3 less than, so let's say this is 100, this should be 100 divided by 3, then you should have 300 divided by 3 is 100, right? Yes. So uh what can we make the base mark on? So we are taking all their marks, then is greater than, let's do greater than 150. No. It's doing it up. I think it is going just going to calculate. I'm coming. Okay, I think this comma here is the reason we are having the error. Sorry, comma is the error. So just put this back. I know you should make the calculation. You are just saying everything here should calculate, then divide it by 3, and if it is greater than 150. We don't have any student that way. That has more than 150 score. You are, sorry, as you can see now. Okay, 100 divided by 3 is 100. So we can never have greater than 150. I'm sorry. So 100 divided by 3. 300 divided by 3 will be 100. So anyone with 100 means they get 100, right? So average score will be 50, and then pass score can be 80, right? Let's do 80. So we have 3 students. That's the 80 overall score. Do you understand now? So that's it. You can just, play with the data, manipulate the data, so and then find. So after this, what is the idea of data science? We know all this, then we take all this data. We already save the data, we have the data, we can manipulate it, we can filter it out, we can sort it. Then we take it into data science, and I mean algorithms like regression, like logistic regression, logic regression, then we can make predictions with it. So that's all we have. Or as a data analysis analyst, you already have your data, then you can use some let's say import matplotlib. I'm not doing this as, no, just telling you what we can use the data for. Plot as plot. So we can just do plot dot plot zplot. Let's do, is there histogram plot. So plot dot histogram d of, then we can have the gender. Let's see what will happen here. There's nothing like histogram here. I think there's histogram in SNS. Let's do the bar uh, pie chart. Pie. It is still, mm, mm. Pi expects what from us? It expects some kind of numbers, right? So we cannot just do it that way. So first we need the gender count. Yeah. So you can now do this, and it should work. As you can see now. So now you can give it some kind of indexing, right? So it will show the gender, and it will. So as you can see here, the reason we have an error before is because we are using direct what? We are using direct list of strings. A pie chart doesn't expect a string for you; they expect kind of number, so they can, you know. they can put it in percentage in this is it. So we have the M and then we have the elf. This is for male and this is for female. So we can give it a name, lt dot uh, title, yeah, gender. You can see lt dot show. So this is the gender distribution. I'm just showing you what we can use our data for after getting it. You know, we did some kind of data. You can create histograms, pie chart, bar chart, all different kind of charts, all the different kind of graphs. You can plot the graphs. So let's plot plotting dot plot. You can do the df. I think the max mark should work. As you can see, this is the plot of the math mark. So you can do scatter. That's a scatter plot of maths and then the words. Let's see what this does. That's it. This is the scatter plot of the maths and then the English thing. So that's all about that. This is not among the what we are doing, so we can just delete it because we are not doing any visualization here. We are just talking about pandas and data frame, and I was free making my research, showing everything I'm doing, making mistakes, because at the end of the day you make mistake to understand these things. Everybody makes mistake, and then we were able to create a lot of things by all starting from this numpy, and we get to pandas, and we get a beautiful what's it called, data frame, and then that's it. Thank you guys, then see you in the next class.